Hello everyone. Hey guys, how are you all? So today we will be having a discussion over the aromatic, anti-aromatic and the non-aromatic compounds. Okay, so this session will help you in understanding the difference between the aromatic, anti-aromatic and the non-aromatic compounds, how we can find it with all the important examples I will be discussing with you right now. Okay, so we will be beginning this particular session and it is going to be a live session. I want everybody of you to interact throughout this session so that the learning has to be big. Okay, so if you are investing your time in watching this session, then there must be some learning. Okay, and I guarantee you, if you stick to this, definitely it would be. So first of all guys, I want you to tell me if my voice and everything is very clear. You please do let me know so that we can begin with. Just give me a message if everything is fine. The session has to be audible and visible, both. Okay. Okay, am I audible?
Just give me a message.
Yeah, I have checked this thing. Okay, so who all are there? I welcome you all guys. Right now we will be discussing aromatic, anti-aromatic and the non-aromatic. Okay, so we will start with the comparison between the three. Okay, so what are the aromatic compounds? Guys, if we need to focus over the aromatic and the anti-aromatic compounds, I will be giving you the very simple points by which you can relate and by which you can distinguish between the three. So the first is, for the aromatic compounds to be, the very first condition that we have to see is the compound has to be a closed cyclic ring. Okay, what it has to be? It has to be a closed cyclic ring. Okay, this is the point. The second point that we have to see for a compound to be aromatic is there must be a planarity. That is, the every atom has to be planar. Okay, every atom which is a part of the delocalization, okay, has to be planar. So means there must be a planarity. Planarity has to be there. That is, every atom has to be sp2 hybridized. sp2 hybridized. In very simple points I am making you write all this so that it becomes very easy for you to solve any question. Now the third point that we have to see is the delocalization. There must be the complete delocalization, not the delocalization, there must be the complete delocalization, delocalization of pi electrons. Okay, complete delocalization of pi electrons. So complete delocalization of pi electron can be seen in the conjugated system. In a conjugated system, that is, what type of conjugated system we could have? Let me give you an example. Whenever we have X double bond Y single bond Z, over the Z, if we have a positive charge or we have a negative charge or we have a lone pair or we have any vacant orbital, if we have any of such condition, or we have a pi bond, even we have one more slash and we have a pi bond. So out of all these 5 conditions, positive charge, negative charge, lone pair, vacant orbital or any pi bond, if we have any such kind of conditions, or I may write it here if it is difficult for you to understand. So over the Z we could have again I am writing, please focus, we could have either a positive charge or a negative charge or a lone pair of electron, or you can say that there must be the vacant orbital and the pi bond. Okay, so I think all the 5 conditions are very clear to all of you. Okay, so over the Z, it could be positive, it could be negative, it could be a lone pair, it could be a vacant orbitals, or it could be a pi bond. All the 5 conditions could be there. Any of the 5 conditions could be there. And the fourth point is it must follow the Huckel's rule. Huckel rule. So what is this Huckel rule is? Huckel rule is the 4n plus 2 pi electron rule. Okay, so that is the number of pi electrons. So Huckel rule basically tells you about the number of pi electrons, that is the electrons which takes parts in delocalization. 4n plus 2 pi electron, that is the number of electrons that participates in the participates in delocalization. Okay, so this is the point that we need to understand. Okay, and this is true, this is 4n plus 2 pi electron is true for the value of n is equals to 0. Here the n could be is equals to 0 or 1 or 2 or 3 or 4. Okay, so we can take any value of n. If I take the value of n as 0, the Huckel rule comes out to be 4 into 0 plus 2, that is 2 electrons. When I put the n is equals to 1, this comes out to be 4 into 1 plus 2, that is 6 pi electrons. Okay, 2 pi electrons, 6 pi electrons. If I will be taking n is equals to 2, here I will be getting 4 into 2 plus 2, that is 8 plus 2, 10 pi electrons. Okay, so if we are getting 2, 6 or 10 pi electrons, then yes, the Huckel rule is being obeyed. Okay, is it clear, Vishnu? Okay, now here let us talk about the anti-aromatic. If you will be focusing over the anti-aromatic compounds, they also must be having a closed cyclic ring. Means the first point is same, they also must be having a closed cyclic ring. First point is same as aromatic compounds, same as in aromatic compounds. Second point, that is a planarity, same as in aromatic, same as in aromatic compounds. Okay, they will also be has to be the planarity. Here in the case of the anti-aromatic, same, the delocalization of pi electron and the conjugated system, means this is also same as in aromatic compounds, same as in aromatic compounds, but the point number 4 is different. So what is this point number 4 is different for the anti-aromatic compounds? The Huckel rule says that as per the Huckel rule, if you are having 4n pi electrons, means see there is a difference, there is a 4n plus 2 and here I am writing 4n pi electrons. So if you are having n pi electrons, then this will obey the, then it is going to be the anti-aromatic compound. So if you are having 4n pi electrons, then it is said to be anti-aromatic. Here also the value of n could be, what could be the value of n? The value of n could be 0, 1, 2, 3, 4, okay, any number. So these are also, this n is also the number of electrons participates in delocalization. Okay, the same, the number of electrons that participates in delocalization, and here if you will put all those values, so 4 into 0, when we put n is equals to 0, so 4 into 0 comes out to be 0 pi electron. Okay, when you will be putting 4 into 1, where the value of n is equals to 1, this comes out to be is equals to 4 pi electron. When we put n is equals to 2, this comes out to be 4 into 2, that is the 8 pi electron. Or when you put n is equals to 3, this comes out to be 4 into 3, that is a 12 pi electron. So whenever we get this much of pi electrons, it is said to be anti-aromatic, and when we get 2, 6 or 10 pi electrons, it is said to be aromatic. So this is the major point of difference that we have to focus. So the point number 4 is different and rest all the 3 points are same in the case of the aromatic compounds and in the case of the anti-aromatic compounds. Is it clear? All those who are watching the session live, please give me a hi or hello so that I get to know. Okay. And guys, you please check the description box. In the description box, we are also going to share the PDF of the session, and we have also given our Telegram link so that you people can join us for the regular updates and the PDFs and the important questions for your JEE Mains examination from this specific topic. Okay, so now let's focus over that what happens in the case of the non-aromatic compounds. Okay, so the non-aromatic compounds are basically the compounds which are either not a closed cyclic ring. Okay, if some of the structure is there and it is not a closed cyclic ring, it is said to be non-aromatic. We can say that it is said to be non-aromatic. Okay, or if there will be no delocalization. Okay, if we are having, okay, let me tell you, if we are having a closed cyclic ring, okay, we are having a closed cyclic ring, We are having a closed cyclic ring. Okay, fine. We are having this particular point that it's a closed cyclic ring, but there is no delocalization. The second point is if there is no planarity, means if there is no planarity, it is said to be non-aromatic compound. If there is no delocalization, no delocalization, it is said to be, it is said to be a non-aromatic compound. Okay, and the fourth rule, that is the Huckel's rule, doesn't obey. Okay, so fourth rule, there is no matter of fourth point, that is the Huckel rule. Okay, so Huckel rule is not applicable for the non-aromatic compounds. Huckel rule is not applicable for the non-aromatic compounds. For the non-aromatic compounds, we just need to see the three things. It is a closed cyclic ring, but there is no planarity, means it's a non-aromatic compound. And if there is no delocalization of pi electrons, obviously of pi electrons, then it is said to be a non-aromatic compound. So I hope all the 3 points are very clear, how we can distinguish between the three. Okay, now I will be taking some of the examples to explain you that how a compound is aromatic, anti-aromatic, or a non-aromatic compound. Okay, now guys, here I will be taking some of the example. Now let's see the example number 1. Okay, you all know what is aromatic now. Now the example number 1 is this. If I have given you this particular structure, okay, now what points you can see? Is it a closed cyclic ring? Yes, the point number 1 is obeyed. It's a closed cyclic ring. It's a closed cyclic ring, right? Yes, this is true. The second point is this planar? Guys, we can see its planarity. How we can see its planarity? See, this carbon is sp2 hybridized, this carbon is also sp2 hybridized, and if you would see, this is a carbocation. Okay, always remember, here I am telling you, जो हमारे कार्बोकेटाइंस होते हैं, whatever the carbocations that we do have, they are always sp2 hybridized, always sp2 hybridized. ठीक है, if you will be having the carbocation of this particular geometry, that is a trigonal planar carbocation, if you do have, then it is going to be always sp2 hybridized. Okay, and if you will be having a carbonyl, if you will be having a carbonyl, carbonyls are sp3 hybridized. But if you are having any carbonyl which is undergoing delocalization, let's say you are having this as a carbonyl and this is undergoing delocalization, means it is undergoing resonance. If it is undergoing resonance, then it is said to be sp2. It is said to be sp2. Are you getting my point? Are you getting my point? Carbocation is always sp2 hybridized, always, because if you are not able to see the planarity, it will be very difficult for you to solve any of the question. So always remember, if you are talking about the carbocation, then the carbocations are always sp2 hybridized. Okay, sp2. Okay, they have a trigonal planar geometry, that's why I am saying they are sp2 hybridized. And if you are talking about any of the carbonyl, so carbonyls are usually sp3. Okay, because of this negative charge, this will exist in the orbital, they will become sp3, they will be tetrahedral in nature. Okay, and if you are having a carbonyl which is undergoing resonance, so because of that resonance, it is will be sp2. Okay, so I am talking about their hybridizations that you have to consider. How all this happens, for all this you need to see my session on hybridization. Now the second point that we were looking here is that is this planar? So yes, this is a carbocation and the carbocation is this is sp2 hybridized. Yes, sp2 hybridized, this is also sp2, this is also sp2. Now the third point is there a delocalization of pi electron? Yes, these pi electrons can delocalize with this positive charge. We can see that this is a conjugated system. How you can see? Yes, this is X double bond Y single bond Z, and over the Z if we are having a positive charge. So I tell you, this is a conjugated system. So if you are having this kind of conjugated system, there will be a delocalization of pi electron. So yeah, we can say that the delocalization is also there, right? Delocalization of a pi electron is also there. And the fourth point is, how many number of electrons are involved? Guys, if you are talking about a positive charge, so positive charge, because of the positive charge, there we have a vacant orbital. Okay, there is no such electron which are participating in the bond formation. Okay, so there it has no electrons, only these 2 pi electrons are participating in the delocalization. So only 2 pi electrons. Okay, now see where this closed cyclic ring sp2 delocalization of pi electron and 2 pi electron. So yeah, all the 3 points are obeying, and 2 pi electron comes here. So ultimately this is obeying 4n plus 2 pi rule, right? 4n plus 2 pi rule. So if it is obeying the 4n plus 2 pi electron rule for the value n is equals to 0, then it is said to be aromatic. It is said to be aromatic. Clear? So aromatic compounds are usually very stable. Clear? Okay, now let me give you one more question. It's a very interesting question, guys. That is the example number 2. Example number 2. Let me take more space for the question to do. Example number 2. Okay, so if I take this as an example, here I am having this as a cyclic ring, and this is this is a pi bond, this is a positive charge, and this is a positive charge. Okay, now my question is whether this is aromatic or this is non-aromatic, or what it is. Okay, so guys, here also we can see that this is a closed cyclic ring. So the point number 1 is this is a closed cyclic ring. We can say that this is a closed cyclic ring. Okay, if you will see the point number 2, this carbon is also sp2 hybridized, this carbon is also sp2 hybridized, forming a bond with the hydrogen. This is carbocation, this is carbocation, this is also sp2, and this is also sp2. So as per me, all the carbocations all are planar. So they all are planar. Okay, sp2 hybridized means it has a planarity. If it has a planarity, see the point number 3. Point number 3 is delocalization. Tell me, Pralay, Vishnu, all of you, tell me, is there will be delocalization or not? Delocalization of pi electrons. Tell me, do we have a conjugated system or not? See, if you would see here, let me use another pen to tell you about it. Guys, see, this is X, this is double bond, Y, single bond, Z. Z over this Z, we have a positive charge. Yes, this is a conjugated system. Even not only this, if you would see here, this is X, this is double bond, Y, single bond, Z, this is positive. So yes, this is also a part of the conjugated system. So both the positive charges are the part of the conjugated system. So yes, there we will be having a delocalization of pi electron. So ultimately what we can understand is the fourth point that we can see, yes, there will be the delocalization as well, planarity as well, and it's a closed ring as well. If you will see the number of pi electrons over this positive charge, there is just a vacant orbital, no electron is there, only these 2 electrons participates in the delocalization, and so therefore the number of pi electrons are 2 pi electron. Ultimately we can say that this is 4n plus 2 pi electron rule, this is obeying 4n plus 2 pi electron rule for the value n is equals to 0. Ultimately this compound is said to be aromatic. Okay, so basically what happens is sometimes students feel, okay, if we will be having a 2 positive charge, then it is not aromatic. No guys, this is not so. Okay, if it is a part of a conjugated system, if a ring is planar, this could be aromatic, and yes, here this compound is aromatic. Now we do have one more kind of examples that we see usually, and we need to learn through them. Okay, they are basically what, let me show you. So basically in the case of the example number 3, now see, in the example number 3 I will be taking such a molecule when we have this and a double bond O. Okay, so when we have this as a double bond O, so this type of double bond O, can we solve this question directly? No guys. So whenever we have this kind of question, we have to rearrange it. How? Basically, as per the electromagnetic effect, this pi bond has to be broken. So when this pi bond will be broken, you will be getting a positive here and negative here. Okay, so first of all we have to break this pi bond, then only we need to answer the question. Okay, and guys, for an aromatic compound we always have to look for the ring, we have to look for the closed cyclic ring. Now if you would see this O negative and this positive, so O negative could be a part of my closed cyclic ring? No, only this is a part of my closed cyclic ring, that is this is the only part of my closed cyclic ring. What? The circle which I have framed means only this is a part of my closed cyclic ring. Okay, so here I need to tell whether it's an aromatic ring or not. So we have to talk about this particular ring. So now if you will see this particular ring, which is a closed cyclic ring, the point number 1 obeys. This is a closed cyclic ring. This is a closed cyclic ring, and here the point number 2 also obeys that this has a planarity. How this has a planarity? As we can see that this carbon is sp2 hybridized because this is the carbocation which is a planar and having a trigonal planar geometry. This is sp2 hybridized, this carbon having a double bond is sp2, this carbon having a double bond is sp2. So yes, they all are having a planarity. The third point is, do we have the delocalization of pi electron, which is an important point to see for a molecule to be aromatic, delocalization of pi electron. So if you would see the delocalization, then absolutely you can see that here we having a system X double bond Y single bond Z, and over the Z we do have a positive charge. So yes, we do have a conjugated system. So there we could expect a here we could expect a delocalization of pi electron. Ultimately, the fourth point and the last point that we have to observe is basically what? Think about it. Of course, the Huckel rule. Now, how many electrons are participating in delocalization? That is the 2 electrons. 2 pi electrons are participating. That is 4n plus 2 pi electron for the value n is equals to 0. So, I am not saying that there must be only 2 pi electron. There could be more than 2 pi electron. There could be 6, there could be 10. But yes, as per this question, this is it. Okay, so as per these 3 examples, you please understand there could be a possibility of 2 positive, 2 negative, or whatever it could be. There could be a possibility of such type of bond. So whenever you have these kind of bonds, you have to break them as per the nature of the atom. This is a polar pi bond, so this needs to be broken. Then only you have to look for the closed cyclic ring and tell whether this is aromatic or non-aromatic. So all the 4 points has to be obeyed for a compound to be aromatic or anti-aromatic. Is it? All of you just say yes. Please be very active throughout the session, okay? It's just not that you have to sit ideal. Now, let's look for some of the examples of the anti-aromatic compounds, okay? So, how we can understand that a compound is anti-aromatic? I will be taking examples which would be new to you, and you will definitely learn something through them, okay? So, here we do have an example number 1. So, example number 1 says that you do have a benzene ring. You do have a benzene ring, and this benzene ring has to react with Fe, that is 2 moles of Fe, 2 moles of Fe. Okay, so you tell me, so when this Fe will be reacting with this 2 moles of Fe, then what we will be getting? You know, Fe is basically a metal, and metals has a tendency to do the loss of electron, okay. So when we will be having an Fe and Fe will do the loss of electron, then Fe will become Fe plus 2, and there will be a loss of 2 electrons. There would be a loss of 2 electrons, okay. So, okay. So let me take here I am having an Fe. Okay, I have given you one Fe. So Fe, what does an Fe do? Fe has a tendency to becomes Fe plus 2 and to gives you 2 electron. Okay, so when Fe will become Fe plus 2, Fe will become Fe plus 2, and this will gives you 2 electrons. So where these 2 electrons will go? So these 2 electrons will be taken by the benzene ring. So ultimately, when these 2 electrons will be taken by the benzene ring, we will be getting this as negative and this as negative. So this will be the structure so formed. Now what the question is asking us, let me draw the structure again. It has to be more clear actually. Okay, now we have to tell whether this compound is aromatic, anti-aromatic or non-aromatic. This is what we have to do. This is what we have to calculate. Okay, so now let me rub this. Fe has become Fe plus 2 with the loss of 2 electron, and these 2 electrons has been taken by the benzene, and this has become the system. Okay, now we have to see whether this reaction is spontaneous or non-spontaneous, whether this compound is aromatic, anti-aromatic or non-aromatic. Now if you would see this closed cyclic ring, is this a closed cyclic ring? Absolutely. The first point is obeyed, that is, it is a closed cyclic ring. Yes, absolutely, this is a closed cyclic ring. Now the second point that we have to see is this planar. Guys, I told you whenever a negative charge is in conjugation with a pi bond, then this particular carbon is also sp2 hybridized. So they are in conjugation. So if this negative charge is in conjugation, so if any carbonyl is in conjugation, it becomes planar. So yes, it is planar. There is a planarity, and we can see that the planarity, this negative will also undergo delocalization with this pi bond. So yes, there is a planarity. Now the third point says that is there a conjugated system? Guys, if you would see this negative, this pi bond is in conjugation, this pi bond is in conjugation, this pi bond, this negative is in conjugation. So yeah, this is a conjugated system, and because of the conjugated system, we can say that the delocalization will occur. Delocalization of pi electron is a part of this system. Delocalization of pi electron will be a part of this system. Now the fourth point is saying that how many number of pi electrons. Now if you would see the number of pi electrons, overall number of pi electrons which are participating in the delocalization, is this negative. This negative tends to 2 electrons. So whenever you have a negative charge, guys, because whenever you will be having a delocalization, the number of electrons participates always in a pair of electron. Okay, there could never be an odd electron, there will always be an even number of electron. Okay, so as per that, we can say that this is equivalent to 2 electrons, this is equivalent to 2 electrons, this is equivalent to 2 electrons, and this is also equivalent to 2 electrons. So 2 2 2 2, we can say that these are the 8 pi electrons. So if they are the 8 pi electrons, they are following 4 and pi electron rule, that is, it's a multiple of 4. So for the 4 and pi electron rule, this is what? This is closed cyclic ring, planarity, conjugated system, 8 pi electron, that is 4 and pi electron. This simply shows that this is an anti-aromatic compound. This is an anti-aromatic compound. Okay, so this is how we have to do the question. Okay, now let me give you one more example. Okay, and it's again a very good example. You can have a look. Let me change the color, because many of the time students say to me, ma'am, please don't use red color, it's not visible to us. Is it? Okay, hi Hari, I hope you are getting it, bache. So here we will be having a look over the example number 2. In the example number 2, this question was asked to me in today's lecture. One of the student asked me, ma'am, what will happen? What will happen? So basically the question was something like this. If you will be having this kind of bond, and this is a Cl and this is also Cl. Okay, now the question is, if you are given with this, and you have to treat it with FbCl5. Now you have to tell that whatever the product formed is, so whatever be the product so formed is aromatic, anti-aromatic, or a non-aromatic compound. So this was the question. So when you will be reacting this with the SbCl5, then what can happen? Let's have a look and then see what could be the right answer. Guys, SbCl5, if you are given with 2 moles of SbCl5, okay, so yeah, so SbCl5 is a Lewis acid. Okay, this has a tendency to expand its octet. Okay, so what can happen? This can form a coordination number 6, SbCl5. So ultimately this SbCl5 will do the loss of SbCl6 negative, and there will be a loss of 2 moles of SbCl6 negative. So when this chlorine will be taken by this particular Sb, that is the antimony, there we will be getting the SbCl6 negative. Ultimately, what will be the product so formed? The product so formed is going to be pi bond. Here we will be getting a positive charge, because when the chlorine will go here, we will be getting a positive over there, and when a chlorine will go there, again with the SbCl5, we will be getting a positive here as well. Is it? Now we have to tell whether the product is aromatic, anti-aromatic, or non-aromatic. So how we can tell? Again, we will be doing we will be checking the number of electrons. Now if you will see the number of electrons, or this is a closed ring, yes, absolutely. The first point is this is a closed cyclic ring. This point is absolutely very clear. This is a closed cyclic ring. The second point is yes, absolutely. The second point is there must be a planarity. Is there a planarity? Let's have a look. Do we have a planarity in this molecule? This carbon is sp2, this is sp2, of course this is carbon is sp2 if you would see their hybridization, and this is a carbocation, and I told you carbocations are always sp2, so this is always sp2, both are sp2 sp2. Okay, so this has a planarity. If it is a stable carbocation, if it is having a trigonal planar geometry, then yes, absolutely it will be sp2. Okay, there is a planarity. The third point is, do we have a conjugated system? Conjugated system or the delocalization of electron. So if you would see the conjugated system, yes, every atom is a part of this conjugated system. You can have a look, this X double bond Y single bond Z, yes, it's a part of the conjugated system. X X double bond Y single bond Z, this is also a part of the conjugated system, and this pi bond and this pi bond also a part of the conjugated system. So they all are a part of a conjugated system. So yes, there could be a possibility of delocalization. So there will be a delocalization. Delocalization of what? Delocalization of pi electron. Okay, because every carbon is a part of that conjugated system. Now the fourth point that we have to say is the number of pi electrons. Now how many number of, over the positive charge there is no electron, only the electron is present here and here. So 2 and 2, only the 4 electrons we do have. So we do have only 4 pi electrons. So 4 pi electrons, it's a multiple of 4 and pi electron system given by the Huckel. So Huckel has given this 4 and pi electron system for what? This Huckel has given this system for the anti-aromatic. So ultimately we could say that this compound is said to be anti-aromatic. Got it? Got it? So this kind of questions where you have to do the reaction and then tell whether the product is aromatic or anti-aromatic can also be asked in your paper. So this is the way how we do the questions. Now let me take an example and will tell you that what happens and how to identify whether a molecule is aromatic, anti-aromatic or water. Okay, so let's see, let's have a look. Okay. Okay, guys, for the compounds to be non-aromatic, I want to give you two most important examples. One of the example is whenever you have cyclobutadiene, please remember cyclobutadiene, butadiene. Okay, so this compound is always be confused with an anti-aromatic compound. Usually students think like this is a closed cyclic ring, planar conjugation is there and it's a 4 pi electron system. So it is usually confused with the anti-aromatic, but it is not anti-aromatic, it is non-aromatic. Why this is not anti-aromatic, this is non-aromatic? Because here we do have an angle strain. Okay, if you will see its three-dimensional structure, you will find that here we do have the angle strain plus torsional strain, angle strain plus torsional strain, and because of this reason the ring is very unstable. The ring is not stable, so no delocalization of electron could takes place. So there will be no delocalization. So because of the angle strain and the torsional strain, no delocalization of pi electron. So when in this particular system no delocalization is there, and no delocalization means what? No delocalization means non-aromatic. No delocalization means non-aromatic. Is this clear? Okay, but when we will be putting N or something hurry, then it will become aromatic. So this is the only case, this is the only exception that I am telling you for the cyclobutadiene. Okay, is it clear guys? So it's not that this is going to be the anti-aromatic, it is going to be the non-aromatic. So this is an exception only for the cyclobutadiene. Okay, when we have the 4 carbons, so this is it. So this is the example that you remember for the examination, but very carefully. Now we do have one more system. If we have a cyclooctatetraene, if we have a compound like tetraene. Now what is this? Guys, this is something like this. See, What is this? Here we have a cyclo-octa. There we have the 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons, and this is a tetraene. This is also an exception. So whenever I ask students, student says that, ma'am, it is a closed cyclic ring. There is a planarity. All the carbons are sp2 hybridized. There could be the delocalization of pi electron. Yes, because we have the conjugated system. And when I asked the number of pi electrons, they said, ma'am, 8. So this molecule is always been confused with the anti-aromatic compound. So always been confused with the anti-aromatic compound. But guys, again, let me tell you, this is not anti-aromatic. Again, because of the angle strain, because of this is also having the angle strain. So because of the angle strain in the same compound, what happens is, because of the angle strain in the three-dimensional structure in 3D, because of the angle strain in 3D, this compound would be something looking like this. Okay, like this. So this is a bond, this is a bond, this is a bond, and this is a bond. Okay, so now you tell me, so is this a planar ring? Is this a planar ring? You know, this is something boat form, boat form. So have you seen a tub shaped tub? Have you seen a tub? So when I'm talking about a tub, when I'm talking about a tumbler, so what has happened? So here, if you will see this particular glass, you will find that this is a three-dimensional thing. Okay, is this planar? No, this is not a planar. So if this is having something like tub shaped, if this is something like tub shaped, then it is not planar. So now there is no planarity, and I told you, when there is no planarity, now there is no planarity in the three-dimensional structure. So no planarity means non-aromatic. Non-aromatic. Now see the points that I have given you on the very first paper, on the very first page. So if there is no planarity, then it is said to be non-aromatic compound, and if there is no delocalization of pi electron, it is said to be non-aromatic compound. Is this clear? So here these two examples need to be carefully understood for the non-aromaticity. They are always been misunderstood by the anti-aromatic, but they are not anti-aromatic, they are aromatic in nature. Okay, now guys, here let me tell you one more question about the non-aromatic, how to find out whether a molecule is non-aromatic. Now see, here I give you an example number 3. If it has been given to you that this is the ring, and here in this particular ring, this is also a ring, and this and this is negative, and this is positive, and this is again a pi bond. Okay, so if it is being given to you, then what you will think of, what you will think, what it could be, whether it is aromatic or it is anti-aromatic, what it could be. Okay, so guys, when we look for one of the ring, see here, if you will see, this is a one closed cyclic ring and this is an another closed cyclic ring. Okay, so we do have two different closed cyclic ring. So here the aromatic and the non-aromatic or anti-aromatic could be given to the two different rings. Okay, so we will be giving answer to this part and we will be giving answer to this particular part. Okay, we have to answer it separately. So if you will see this particular ring, you will find that there is a delocalization. See, when you will see this particular ring, what you will find that here this is a closed cyclic ring. Yes, this is a closed cyclic ring, and in this closed cyclic ring there is a planarity. Now yes, you will say that this part is closed ring, and there is planarity as well. Why there is planarity? We can see that the carbons which are doubly bonded are sp2 hybridized, and if this negative charge is in delocalization with this pi bond, if there is a resonance between a pi bond and a negative, there is a planarity. The third point is there is a delocalization of this negative electron. Yes, there is a delocalization as well. We do have a conjugated system. Yes, delocalization is also there. If you will see the number of pi electrons, then you will find that they are the 4 pi electron, which is a multiple of 4, that is the 4n pi electron system is followed. Then you will say that, ma'am, this is anti-aromatic. This is what you will shout on, ma'am, this is anti-aromatic. Is it guys? Okay. Okay, now let's have a look over this particular ring. If you will be focusing over this particular ring, this is again a closed cyclic ring. Absolutely, this is a closed ring. Now if you would see the planarity, yes, there is a planarity. The carbons are planar in nature. This carbon, and the carbon which is having a positive charge, this is also planar in nature. Now if you would see the delocalization of pi electron, what it could be? Delocalization of pi electron, will there be occur? Yes guys, because here we can see that this is a conjugated system, X, double bond, Y, single bond, Z, and over the Z we do have a positive charge. So this is a part of our conjugated system. Ultimately, the first point, second point, third point is clear. Now the fourth point, how many number of electrons? Only 2 pi electrons. 2 pi electrons means what? This is a 4n plus 2 pi electron system when we will be putting n is equals to 0. So ultimately this is a Huckel's rule, and this is which rule? This is a rule for the aromatic. So this part is aromatic. So guys, one of my ring is aromatic, another ring is anti-aromatic. Okay, so when one ring is aromatic, another ring is anti-aromatic. So overall what this compound is said to be? So what this compound is said to be? This is anti-aromatic, this is aromatic. So ultimately what we could say, is this having any benzene ring? Guys, you know, when you will be having some benzenoid compounds, okay, in the benzenoid compounds are basically such compounds where we do have at least one benzene ring, is said to be aromatic in nature. But in such a compound, when one is anti-aromatic and the another is aromatic ring, okay, then such a compound is said to be. Then how to decide? Yes, it's a very question. Then how to decide? One ring is anti, one ring is arrow. Okay, then in such a case the overall molecule is said to be, in such a case the overall molecule is said to be non-aromatic. Non-aromatic. In such a case a molecule is said to be non-aromatic. Is it clear? Is it clear? This molecule is said to be non-aromatic because the characters are just opposite of each other. Aromatic is highly stable, anti-aromatic is least stable. So here we would consider that a molecule is said to be non-aromatic. Okay, but at the same time, let me tell you, if you will be having some any kind of the benzenoid compounds, okay, so in this case aromatic compounds, let me take the example number 4. If you will be talking about the example number 4, let's say if you are having any kind of benzenoid compounds where we do have a benzene and we do have any kind of other part like this or this. Okay, now what could you say if there is any such example like this or any such example like this where you have a one benzene ring and the another ring which is not anything. So here what you would say, so ultimately this is a closed cyclic ring. So this is a closed cyclic ring. If you will focus over this particular closed cyclic ring, you will say that yes ma'am, this is a closed cyclic ring. This is a closed cyclic ring. You would also say that here the every atom is planar, there is a planarity, there is a delocalization, and the number of pi electrons are basically 6 pi electrons. Ultimately this is obeying the 4n plus 2 pi electron rule, and ultimately guys we can't ignore that this is a benzene and we know that this is a benzenoid compound. So overall, in simple words, what I can say that this is a benzenoid compounds. So when we have the benzenoid compounds, okay, so when benzenoid compounds are such compounds which have at least one benzene ring. So whenever we have at least one benzene ring, such benzenoid compounds are said to be aromatic in nature. They will always be aromatic in nature. Always be aromatic in nature. Okay, so if in any of the compound we do have at least one benzene ring, such compounds are said to be the benzenoid compounds with at least one benzene ring, and they will always be aromatic. Okay, now here if you would see this particular benzene, and this is also a ring, but we can see that again this is having one benzene, so this is also said to be an aromatic compound. This is also said to be an aromatic compound. Is it clear? So all the benzenoid compounds having at least one benzene ring is said to be an aromatic compound. Okay, now I want to discuss with you one more question which is very important from the examination point of view, and I hope all these points I made very clear. Okay, so many of the times students are having few of the doubts in few of such questions. Let me tell you such examples. You do have a doubt in such kind of compound, that is benzene. So what is this? This is known as benzene. Ma'am, in the case of benzene, do this aromatic, anti-aromatic or non-aromatic? What it would be? Now guys, you can simply see that here this is having a closed cyclic ring. closed cyclic ring. Okay, if you have to see the planarity, then you can see that there is a planarity. How there is a planarity? This is the carbon which is sp2, sp2, sp2. Guys, this is also planar, right? If it is a linear structure, if this is an alkyne, so alkynes are always linear, you know, they are sp hybridized. Okay, so they are sp, but sp is also planar. So I said that there has to be a planarity. Whether there would be a planarity because of the sp2, there is a planarity because of the sp2, or there is a planarity because of sp. So both are basically contributing for the planarity. So yes, this is also planar. Now the third point is, do we have the conjugated system? Yes, we do have the conjugated system. So now can you please mark the conjugated system, those who are undergoing delocalization? So when I have to mark the conjugated system, I know that this pi bond is in conjugation, and this pi bond and this pi bond is in conjugation, and this pi bond and this pi bond is in conjugation. Okay, so these are a part of a conjugated system. Now what would be the last point? The last point says that the number of pi electrons participates, please listen it carefully, participates in a delocalization. Now how many electrons are participating in delocalization? Anybody would tell me? Anybody would tell me how many number of electrons are participating in delocalization? Any answer? These two pi electrons, these two pi electrons, these two pi electrons. So from here, from between these two carbons, how many pi electrons will participate? 4 or only 2? Guys, only 2 electrons will participate from the in conjugation. Only 2 electrons, 1 2, 1 2 and 1 2. Only 6 electrons will participate in conjugation. In short, I can say that the number of electrons participates in conjugation are 6 pi electron. And if they are 6 pi, this will be 4n plus 2 pi electron rule. Ultimately, this is obeying the Huckel rule. Huckel rule. So this is said to be aromatic in nature. So benzene is also aromatic in nature. Okay, so don't please count that in the case of the benzene we do have 8 electrons. So many of our time students misunderstood this thing that this pi electron will also participate. No guys, for the delocalization we just need 2 electrons. Okay, so if something is there extra, then you need not to take it compulsorily. Now one more last example if I want to take. And if you do have any doubt in any of the questions, you please let me know. And otherwise from my side, this is the last example to make you understand all about the aromaticity or the non-aromaticity or the anti-aromaticity. The question is something like this. Okay, and yes, okay, so this is a question. So if this kind of question comes to you and the question asks you that whether this is aromatic, anti-aromatic or non-aromatic, so how would you answer? Okay, how would you answer? So first of all guys, we need to rearrange this particular structure into what? So delocalize it and reframe it. You will be having a pi bond there, you will be having a pi bond there, this is a methyl, methyl, this is O. This pi bond needs to be broken, because if this will be like this, it will be very difficult for us to understand whether what to do or what not to do. So we know that this is a polar pi bond, and when this bond needs to be broken, here over the O we will be getting a negative charge, and over the carbon we will be getting a positive charge. Now this is correct. And over the oxygen we do have a 2 lone pair of electrons. Is it clear? Okay, now we have to see whether what type of conjugation we do have in this question. Now when you do this question, you please see, is this a closed cyclic ring? Is this a closed cyclic ring? Absolutely, this is a closed cyclic ring. Please don't ignore this particular point. That is the very first point. If you will see this particular part, if you will see this part only, which is a part of a closed cyclic ring, whatever been attached, this methyl or this O negative, you please ignore that part. Just focus over the closed cyclic ring. We just need to focus over the closed cyclic ring. Many a time student count this particular electron. Why? Is this a part of a closed cyclic ring? No. So please ignore this part. Just focus over the part which is under the ring. Now here we will start looking at, okay, is this planar? Please check its planarity. Planarity is there or not. This carbon is sp2, this carbon is sp2, sp2. If you would see this oxygen, this would look like sp3, but you know, resonance changes the hybridization. I told you this thing in my one of the previous lecture. So resonance changes the hybridization. Resonance changes the hybridization. So here it would look like sp3, but when this when this lone pair will undergo delocalization, this will become sp2. So this is also sp2. This carbocation is always sp2. This oxygen is also sp2, sp2, sp2. So yes, we do have a planarity at every atom. Every atom is having a planarity. Now the third point that you have to see, the delocalization, that do you have the conjugated system? Now please look for delocalization or for the conjugated system. Conjugated system, if you will be having a conjugated system, then only there will be a possibility of a delocalization. Now let's have a look. So this lone pair will be having a conjugated system with this pi bond. This pi bond and this pi bond are having a conjugated system. This pi bond and this positive charge is making a conjugated system. So ultimately every atom is a part of that conjugated system. This lone pair, this pi bond and this pi bond and this positive charge, yes, there is a conjugated system. Now the last point is the last point that we have to focus over here is the number of pi electrons. The number of pi electrons, anybody would tell me how many number of pi electrons are basically participating in delocalization? Tell me how many number of pi electrons? See, over the oxygen we do have these two lone pairs of electron, two electrons, these two electrons, two more electrons and these two electrons. So 2, 2 and 2, that is 6. Over this positive charge, do we have any electron? No, we don't have any electron. So ultimately the total number of electrons participating in conjugation is basically 6 pi electron. And if they are 6 in number, this is basically obeying 4n plus 2 pi electron rule. Ultimately this is said to be aromatic in nature. So with this one session, this 1 hour session, I tried to cover every such example where you people get confused and which are very important from your examination point of view for the IIT JEE mains or advanced paper and as well as for the NEET aspirants. Okay, so guys, if you do have any other doubt, please do let me know. If you want me to answer any of the question which is like moving in your mind, then please do let me know. I am giving you a minute or two. So this is it for today's class. Okay, so ultimately the whole thing which I summarize over in the at the very first page, you have to focus the aromatic compounds, the anti-aromatic compounds and the non-aromatic compounds. The aromatic and the anti-aromatic, they are mostly same. They are just having a difference in the point number 4. So over the point number 4 we have to focus, and here to compare between the non-aromatic compounds, you please focus over the no planarity and no delocalization. If there is no planarity, no delocalization, it will lead to non-aromatic compound. Is pyridine also an aromatic compound? Absolutely. Pyridine is an aromatic compound. Now let me tell you how. If this is a question asked by Hari, so let me take the example number 3. He is asking, ma'am, if we will be looking for the pyridine. Okay, this is the structure of a pyridine. So is this aromatic, anti-aromatic or non-aromatic? Hari, you tell me. You always confuse about this lone pair of electron which is over the nitrogen, right? That's why you are asking this question, right? Because you are thinking that it has 8 pi electron. So you tell me, this is a closed ring. Yes, you know this well. This is a closed cyclic ring. If I ask you about the planarity, you would say, ma'am, okay ma'am, every atom is planar. Even this nitrogen is also sp2 hybridized. This is also planar. So yes, there is a planarity. If I ask you, bacha, the conjugated system, can you tell me who will participating in the conjugated system? Who are a part of this conjugated system? Think about it and then do let me know. Conjugated system, see, this pi bond will be in conjugation with this pi bond, this pi bond is in conjugation with this pi bond, this pi bond is in conjugation with this pi bond. So how many electrons are participating in conjugation? How many pi electrons are participating in conjugation? So only 6 pi electrons are participating in conjugation, not 8, only 6. Only 6 pi electrons are participating in conjugation, are participating in delocalization or in conjugation, delocalization. So yes, this is a 4n plus 2 pi electron rule and this is aromatic. This has to be aromatic. So please don't confuse with this lone pair. You know, this lone pair is perpendicular to this particular ring. this lone pair is perpendicular to the ring. So if this is perpendicular to the ring, this cannot participate in the delocalization. If we do have these electrons, the one which are in red color, then what's the need of this lone pair of electron to participate in conjugation? Okay, so the internal pi bonds will participate in delocalization. So ultimately the number of electrons are 6, and hence it is said to be aromatic. Any other doubt, guys? So this is it for today's lecture. I hope this has helped you, and for many more such lectures you please keep watching me on an academy. And guys, do subscribe, share this session, and if this has helped you on GOC, I have also taken many other sessions like what could be the electronic displacement methods, how you can understand more on resonance, what are the game changing rules of the resonance, how resonance becomes a game changer for you all, how to determine the stability of the resonating structure, because many of the questions we have to answer from the most stable resonating structure. So for the resonance stability, I have discussed many such points which are very easy that you must go through. So whatever the lectures I have taken in the they have been added in the playlist, so please watch it one after another, and it is going to be very helpful. I definitely guarantee you this thing, guys. Okay, so you do follow me on an academy over, I might be new over the YouTube, but I am so old over the academy. I do have 127,000 followers over an academy, those who are the students, those who have learned through me and my courses. I do have 32 million watch minutes, 6,000 dedications. Many of the students have dedicated their hats to me, their learning hats to me, and this is all about, I want to say, guys. Many of the students are like don't know about my profile. You please visit an academy and you will be able to see that I am also an all India rank holder 25 in the CSI UGC net in December 2015 examination. So I do have a trusted name, so you just trust is the main thing that I expect from you. If you keep a trust on me, then definitely I give you a guarantee that within this year I will make the chemistry portion very interesting to all of you. Okay, and if this would interest you, then definitely you will be able to put maximum efforts or maximum hard work in the particular subject. Okay, this is it, guys. Thank you so much. This will guarantee you 4 marks in your JEE mains paper. Bye bye, take care, see you in some other sessions.